This mission has proven to be difficult due to the limited number of resources. The materials provided are only as follows. Yarn. It is a long thread or string, oftentimes made of fiber with a cotton-like texture. However, only 1 meter of it is provided for the mission. This material can be used for attaching two strings, tying, and due to its softness when crumpled, can also be utilized as a cushion. Manila paper. It is a type of inexpensive paper generally made through a less refined process of semi-bleached wood fibers. For this mission, 1/2 of the Manila paper is provided. This material can be utilized to create enclosures or capsule, can be crumpled to imitate a cushion, or folded to increase surface area. Masking tape. This is a type of adhesive material which can be used for sticking one material to another. Only 1 meter of the tape can be used for the mission. Most of the materials are inexpensive, which sums up to about 40 pesos. However, there have been less expensive since most of the materials are readily available at homes.
A box made using the Manila paper was utilized in order for the raw egg to not crack. We used the parachute method that also was made up of a Manila paper with the yarn that was stick together, using the tape on it to increase air resistance, and that causes the egg to hit the ground at a lower speed. The egg was reinforced by the use of the 1 meter tape to wrap the egg from its tip to the bottom that helps to absorb the impact of landing.
The physics of an egg drop. There are 3 forces to consider during the egg drop. First is the gravity. Gravity is the force that pulls objects towards each other. On our planet, objects are pulled towards the center of the Earth, which causes them to fall downwards. Second is the drag. Drag is often called air resistance. Drag is when forces are acting in the opposite direction of the motion of an object. Lastly, impact. Impact is the high force or shock applied over a short period of time when 2 or more objects collide. The effect depends on the relative velocity or speed of the 2 objects to one another. Newton's laws were also applied to the experiment. First, an object at rest tends to remain at rest, and an object in motion tends to continue moving in a straight line at constant speed, unless an outside force acts upon it. The egg will not fall unless it is dropped, or an object at rest. While at rest, the egg has potential energy. The egg gains potential energy as it is transported to a higher elevation for performing the egg drop experiment. Once dropped, it will fall. This demonstrates kinetic energy. It will be acted upon by the following forces. A. Gravity, which will pull it towards the Earth and cause its speed to accelerate. B. Drag. Depending upon how the egg protector is built, this will vary, but drag will slow the fall of the egg down. Drag does not destroy kinetic energy, but instead creates friction between the air and the object, creating drag, and as a result transfers the energy into heat energy or another form of kinetic energy. Last is the impact. Ultimately, the egg and its protector will hit the ground. The size and amount of the impact will depend upon the speed with which the egg and protector were falling. The second law that was applied to the experiment is force equals mass times acceleration. The egg will accelerate based on the pull of gravity. How much it accelerates depends on the height from which the egg was dropped and the mass of the egg and protector. Force will increase with larger masses and higher heights. The last law that was applied is for every action there is an equal and opposite reaction. The egg will hit the ground. It will exert some amount of force on the ground when it hits. The ground will, in turn, exert that same amount of force on the egg. The first law of thermodynamics was also applied. Energy can neither be created nor destroyed. The potential energy the egg has when it is at rest is converted into kinetic energy as it falls because of the force of gravity. Energy can be transferred from one kind to another, but it is never destroyed. When the egg hits the floor, the kinetic energy is transferred again, this time to the egg and the packaging materials used in building the egg protector.
Step 1. Following a template, cut out the manila paper to form a box measuring 5 cm by 5 cm by 10 cm bonded by the masking tape. Step 2. Cut the yarn into 4 equal parts and attach one to each side of the box. Step 3. Cut out a rectangular piece from the excess manila paper and join each corner to the ends of the 4 yarn. Step 4. Using the remaining tape, reinforce the egg by wrapping the tape around the egg.
1 meter drop. Survive. Two-meter drop. Survive. I failed.
The box with the raw egg inside survived at the 1 meter height, but unfortunately it did not survive when it is dropped at 2 meters height and at second floor due to gravity acceleration, because the increase in height resulted to the increase in acceleration when falling due to gravity. The attempt of parachute to increase air resistance and decrease the speed was backfired or is not enough. The device has failed to decrease the impact towards the egg, therefore results to the breaking of the egg.
The device was disassembled and separated, resulting to the following cases. First, the manila paper from the parachute. Second is yarn. Third is a portion of manila paper from the box. And fourth is the tape that was around the egg which gotten wet from the egg breaking. To effectively manage the waste disposal, 3 R's have been followed: reduce, reuse, and recycle, as well as proper disposal, whether biodegradable, non-biodegradable, or recycle. The manila paper and the yarn recyclable. Wet tape and manila paper are biodegradable. The excess egg has been wiped with tissue and thrown in biodegradable.